Here's a finding that should stop you. Researchers have proven mathematically that the common definitions of algorithmic fairness are incompatible, not difficult to satisfy together, impossible, except in trivial cases you'll never encounter in the real world. So, the moment you choose a fairness metric, you have chosen which kind of fairness to sacrifice. Now, think about what that means. When your team reports the model is fair, the honest sentence is the model satisfies the fairness definition we picked and violates the others. Did anyone tell your board that? Did anyone choose which definition deliberately, or did it come as a default in a library? In this chapter, we take the 4 human-facing characteristics. You learn what accountability and transparency actually require, and why transparency operates at 3 different layers. The genuine difference between explainable and interpretable, and why post hoc explanations may be plausible stories rather than truth. Privacy in AI, including risks that survive anonymization entirely. And fairness, where bias comes from, how to find it, and how to manage it across the life cycle. By the end, you'll be able to spot the difference between a system that's genuinely accountable and one that's simply produced a document. Let's get into the uncomfortable half. So let's start by separating 2 words that always travel together: accountable and transparent. Transparency is about visibility. Can you see what the system is, what it does, how it was built, what data it used? It's a property of the system and its documentation. Accountability is about answerability. When this system causes harm, who is responsible? Who has to explain, fix it, and face the consequences? It's a property of your organization. And here's the crucial point. You can have one without the other, and both failure modes are real. Transparent but not accountable. Everything is documented beautifully, and when it goes wrong, everyone points at someone else. The data team blames the business blames the vendor points at the contract. Full visibility, zero answerability. Accountable but not transparent. Someone's clearly responsible, they've signed for it, but they can't actually see inside the system to do anything about it. That's unfair to them and useless for control. Remember the data scientist I mentioned who owned 10% of the decisions and 100% of the blame? That's an accountability failure. Responsibility landed where control didn't. So here's the test. For each of your AI systems, name the person who answers if it fails. A named human. If you get a committee or a shrug, you don't have accountability. You have a diagram. So transparency isn't one thing. It operates at 3 layers, and I want you to see them separately because organizations routinely nail one and miss the others. Layer 1, the algorithm. What model is this? What are its inputs? How does it work broadly? This is the layer people think of first, and honestly, it's often the least useful to a non-expert. Telling an affected person you used a gradient-boosted ensemble helps them not at all. Layer 2, the process. How was this built and governed? What data trained it? Who reviewed it? What testing did it pass? What were the design decisions and who made them? This layer is often the most important for accountability, and it's the one most often missing because nobody wrote it down at the time. Layer 3, the outcome. Why this specific decision for this specific person? This is what the affected individual actually wants, not how the model works in general. Why me? Why this? And what can I do about it? Here's a real example. A bank could tell me everything about their model architecture. Layer 1, perfect. But when a customer asked why they specifically were declined, the bank couldn't say. Layer 3, absent. And layer 3 was the one with legal consequences. So ask, transparent to whom and for what purpose? The engineer, the auditor, and the affected customer need 3 completely different things. So here's another pair that gets muddled: explainable and interpretable. And the distinction is actually useful, so stay with me. Interpretability is a property of the model itself. An interpretable model is one you can understand directly by looking at it. A small decision tree, a linear model with a handful of weights. You can trace the logic yourself. The transparency is built in. Explainability is what you reach for when the model is not interpretable. When it's a deep network with millions of parameters that no human can trace, you bolt on a separate technique that produces an explanation of what it probably did. See the difference? Interpretable means the model is inherently understandable. Explainable means we've added a tool to approximate an understanding of a model that isn't. And here's the tension, which connects back to our trade-offs. The most accurate models tend to be the least interpretable. So you're often choosing, use a simpler model you can genuinely understand, or a complex one you can only approximate an explanation for. When should you insist on interpretability? When the stakes and the accountability are high. A model denying medical treatment, I'd argue, should be interpretable, even at some cost to accuracy, precisely because you need to genuinely understand it, not tell a story about it. Which brings us to the danger of those stories. That's next. So let's get into the two distinctions that determine whether your explanation is actually trustworthy. This is slightly technical, but it protects you from being fooled, so it's worth it. First distinction, global versus local. A global explanation tells you how the model behaves overall, which features matter across all decisions. A local explanation tells you why this one decision came out this way, and they can disagree. Globally, income might be the biggest driver, but for this particular person, something else flipped the decision. The affected individual needs the local answer. Your governance team needs the global one. Different tools. Second distinction, and this is the one that should make you cautious. Post hoc versus intrinsic. Intrinsic means the explanation comes from a model that's transparent by nature. Post hoc means you trained a complex, opaque model, and then afterward you ran a separate technique to explain it. Here's the problem with post hoc. That explanation is itself an approximation, a second model guessing at the first. It can be plausible and wrong. It can produce a confident, reasonable-sounding story that isn't actually why the model decided. Think about that. You show a customer an explanation, it sounds sensible, and it might be fiction, generated after the fact to make the decision look reasonable. So the question I'd ask your team, is this explanation intrinsic or is it a plausible story we generated afterward? Because you may be defending a decision with a narrative, not a reason. So let's talk privacy, and I want to start by expanding what you think privacy means, because AI breaks the usual definition. The traditional privacy principles still apply, and they matter. Collect only what you need. Use it only for the stated purpose. Keep it secure. Let people access and correct their data. If you've done GDPR or DPDP work, this is home ground. But here's where AI is genuinely different, and this catches privacy teams out. Privacy law was largely built around collection. Did you collect this data with consent for a purpose? AI shifts the risk from collection to inference. The model doesn't need to collect a sensitive attribute. It infers it. It can predict health conditions from shopping patterns, sexual orientation from behavior, pregnancy from purchase timing. You never collected the sensitive fact. The model deduced it. So your consent form is now beside the point. The person consented to sharing what they bought. They did not consent to your model concluding they're unwell. I worked on a project where marketing wanted to target based on model-inferred life events. Technically, no sensitive data was collected. Ethically and reputationally, it was a minefield because the inference was the sensitive act. So the privacy question for AI isn't just what did we collect, it's what can this system deduce and did anyone agree to that? So how do you actually protect privacy in AI systems beyond writing a policy? Let me walk you through the real tools at a level you can discuss with your team. Start with the one everyone reaches for and the one that fails most: anonymization. Strip the names, strip the IDs. The problem? Re-identification. Combine a few supposedly anonymous fields, and you can often pin down an individual. Famous studies re-identified people from datasets that looked perfectly anonymous. So anonymization is weaker than people assume, and I'd never rely on it alone. Then differential privacy. This is cleverer. You add carefully calibrated mathematical noise so that the presence or absence of any single individual can't be detected in the output, while the overall patterns survive. It gives you a genuine, provable guarantee at some cost to accuracy. That's the trade-off again. Then federated learning. Instead of pulling everyone's data into one place, you send the model out to where the data lives, train locally, and bring back only the learnings. The raw data never leaves the device. Your phone's keyboard prediction works roughly this way. And synthetic data. Generate artificial data that mirrors the statistical shape of the real thing without being any real person's record. So the point I'd leave you with, privacy in AI isn't a checkbox. It's an engineering choice made early with real trade-offs. Retrofitting it is far harder than building it in. So we arrive at fairness. And I want to start with the honest, uncomfortable truth I opened the chapter with. There is no single definition of fair. Let me make that real. Imagine a model used in lending. One definition of fairness says, approve people at equal rates across groups. Another says, among people who would actually repay, approve at equal rates across groups. A third focuses on equal error rates. These sound similar. They are mathematically incompatible whenever the groups differ in the underlying base rate, which they almost always do in the real world. So you cannot satisfy them all. You must choose. And that choice is not a technical decision your data scientist should make quietly in a notebook. It's a values decision, and it belongs in governance. Notice too the exact wording NIST uses. Fair with harmful bias managed. Two careful choices there. Managed, not eliminated. Because bias cannot be fully eliminated, only understood and controlled. And harmful bias, because not every statistical difference is a harm. A model that predicts pregnancy risk differently by sex isn't unfair. Context decides what's harmful. So the fairness conversation isn't which model is fair. It's which definition of fairness fits this context. Who decided that, and what does it cost the groups it deprioritizes? If nobody in your organization can answer who chose your fairness definition, it was chosen by default. Let's see where the bias comes from. So where does bias actually come from? Because if you think it's just biased data, you'll only fix a fraction of it. Let me give you the main sources. Historical bias. Your data faithfully records a world that was unfair. Train on historical hiring, learn historical discrimination. The data is accurate. That's the problem. It's accurately capturing injustice. Representation bias. Some groups are underrepresented in your data, so the model simply works worse for them. The classic case. Facial recognition performing poorly on groups scarce in the training set. Not malice, absence. Measurement bias. Remember the spending as proxy for need case? That's this. Your label measures one thing and you treat it as another, and the gap between them tracks a protected group. Aggregation bias. One model for everyone when different groups genuinely need different treatment. A medical model calibrated for one population applied to another. And deployment bias. The model is fine, but how it's used in practice creates the harm. So how do you detect it? Slice everything. Never look only at overall performance. Break every metric down by group and look for gaps. A model that's 94% accurate overall might be 98 for one group and 80 for another. The average hid it. So the discipline is simple to say and rare to do. Never report an aggregate without the breakdown underneath it. So once you've found bias, how do you manage it? And the key insight here is that mitigation isn't one step. It's opportunities across the whole life cycle, and where you intervene matters. Think of three stages. Before training, you work on the data. This is pre-processing. Rebalance underrepresented groups, correct sampling, address label problems. The advantage of fixing it here is that it's fundamental. The limitation is you can't always undo history baked deep into the data. During training, you constrain the model itself. You add fairness objectives alongside accuracy, so the model is penalized for disparities as it learns. This is powerful, but it's where that impossibility result bites. You're forced to pick which fairness definition you're optimizing for. There's no dodging the choice here. After training, you adjust the outputs, different thresholds for different groups, or post-processing to equalize outcomes. Effective, but sometimes legally and ethically fraught because you're now treating groups differently by design, and that has to be justified carefully. Now, here's the point that ties the whole framework together. Notice this isn't a test you run once before launch. It's continuous. Bias can re-emerge as data drifts. The fair model you shipped can become unfair over time silently. So mitigation isn't a gate, it's a discipline you maintain, which is exactly the socio-technical lifecycle thinking the whole framework keeps returning to. So let's gather up the human-facing half. First, accountability and transparency are different. Visibility versus answerability. And the test for accountability is brutally simple. Name the human who answers if it fails. A committee is not an answer. Second, transparency has three layers: algorithm, process, outcome. The affected person wants the outcome layer, why me, and it's the one most often missing. Third, be very wary of post hoc explanations. They can be plausible stories rather than real reasons. Ask whether your explanation is intrinsic or a narrative generated afterward. Fourth, AI privacy risk has moved from collection to inference. Your consent form doesn't cover what the model deduces. Ask what this system can infer, not just what it collected. And fifth, fairness has no single definition, and the common ones are mathematically incompatible. So somebody chooses, and that choice is governance, not a library default. Never report an aggregate metric without the group breakdown underneath it. If you want a detailed, structured course on this topic with role plays, quizzes, and practice tests, our Udemy course link is in the description. Do subscribe to the channel if you're getting value from this, and the playlist link is in the description with every video in the series in order. Next, we start the 4 functions properly, beginning with govern. See you there.